Hello everyone, now we are looking at the lab 7 lab exercise. In this lab exercise, the task is pretty huge. For me personally, it took me more than 5 hours to finish the coding for this section. Wow, so it may take longer time for you if you try to do it by yourself. Therefore, it's okay just to watch the solution and also maybe copy some of the code and try to play around with it, because definitely the programming skill, you get the skill through practice, right? And also through this kind of really large project, right? So to develop your programming skills. Okay, so for this week, we continue working on the Java animation project, and look that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 exercises, right? We look them one by one, right? Okay, so the first one is to create game config class, right? Because originally we have some configuration with the game, but this information is stored in the game classes, so that is probably not right. It's better to have a separate game config class so that it store the game config information, and the game data is related to when you play a game, right? So these are separate. So we configuration data from the game class into the new class, one instance of, because for this system we only need one instance for the game config, so we try to use singleton pattern, globally accessible config screen and other class too. So this is not so difficult. We create game game config class, right? So we have the right, maximum size, minimum size. So this new item, so the size, color string has shadow, right? So this is more like a project class, just exercise restore this. We try to make it as a singleton. So once we create, then we use private as a constructor to make it not able to be create instance from other part, right? The initialize, and we have a private static class in here, internal class. So it return this instance. So we use this build back way to create singleton design pattern. Okay, use get instance, we create internal class instance, right? Create this one. So get color, get size, so on. So this is just the function we have been used before, but originally they are in game classes, and now we move to here. But of course, once you change all this element, all this information in this class, then you need to adjust the configure screen, right? So the configure screen, they're going to use originally is used the game, but now it's not game, right? So the implement screen originally is implement the screen with game because it require the game information. But now this configure screen doesn't depend on the game anymore. It's only relate on the game config, and game config we can access as a global one. So therefore, we don't need to define them, right? Here we have set as a game config, right? So we use this as a global one, maximum size, minimum size, and also get instance, get size, right? We use this to replace the game. So the first one is not so difficult, but now we look second one, introduce game entity, right? So this is a big step because the original design is we have um, the game pen and they hold the visual element there, right? And then we introduce sprite, and sprite is still the concept in the UI section. Now we want to have this relate to the game section, so the game data model section. So here we have the game entity. So that is abstract class, right? now we have two subclass. One is player, because we have player move around, so that's one game entity. And another one we put as food, right? So originally we created stars on the screen, but star is the concept in UI section. Now we need in the model section, so we used food, right? Create entity type, and here, okay, we look at game entity. So this UI section, the model section, right? We have game entity, right? So for game entity, we have the double the position, the movement, deactivate movement, right? Size, right? Burst time. We use this as a way to control the entity, how long it has been lived, right? When it's burst, previous time. So this part is used for calculate the time span, right? Life. Also, the game entity may live for some time. -1 means eternal life, so that we live forever. Otherwise, it's how many seconds remain, right? So game entity here, previous time, life equals -1. We assume the game, the entity can live forever, right? Get remain time. Here we check how long it can last. If equals -1, return -1, right? So internal life will not change. Otherwise, past life equals system, this current time minus birth time and divided by 1 billion, right? Because it's a nano time. We need to calculate it to second. So this come to second. We cast it to integer because they are the data type is long, right? So we cast it to integer. And remain life is life minus past time, right? Okay. I return max past remain life and 0. So if return 0, that means it's going to die, right? Okay. It's bounced, so we use this default is true, so we control this entity. If they move on the screen, they bounced in the boundary, right? Process move. So this one is the logic we have used before, but this part, look here, we ask frame time independence movement. The reason is the process move could be called by the animation timer in the game pane. So that timer can be called, typically it's around 60 times a second, but the real number of times to be called by them is depends on hardware. Therefore, in order to make all the game perform consistently, so we use the process, we use the current time equals this current time, and if this is 0, because dx dy equals 0, that means that's just stationary. So that's this entity will not move, right? So return. Otherwise, we calculate step is current time minus previous time divided by 20 million, right? So because there's the nanosecond, so we convert this so that generally we calculate how many steps in 50, right? 50, that means 1 second takes 50 times, right? So that's the steps. If there's the 50, so that's going to be 1 step, something more or less like that. Okay, and now we have the steps dx, right? So because in previous design, we just directly use x plus dx, new movement. Now we use steps times that, right? So the steps could be more than 1, could be less than 1, right? So let's make adjustment, make the movement more consistently, right? So it's bouncing, we check if out of boundary, we change the direction of the dx and the dy, max and my. And after that, if not bouncing, of course, we don't need them. X plus here, Y plus here, previous time. So this section is just to control the movement. And this additional design makes the move speed consistent in different kind of hardware. So it's visible. We look at if this object X smaller than this, larger than them, otherwise they become false, right? Become false. So that if that's x smaller than minus size. So the x is the center point of this object. Right? So if less than size, minus size, or y less than this, or x larger than that, they are invisible. Otherwise, true. So instead, you see all this because in the abstract class they could be override by the child class. Instead, if get remain life equals 0, return true, right? Okay. Otherwise, if not visible, also true, right? This is collide. This, you look at the function. So it's now usage h. So it just introduced at this stage, but not used yet. We probably reserved for future usage. Abstract process, right? And abstract get type when you want to know what type of this entity, right? So here is get x, set x. So this just this typical thing related to the movement. Get set aside, right? Okay. So this is the game entity. Store all elements, the game player and the multiple force in the game list. Okay, now we look at the game. In the game, we have player, right? So there's a special entity. So that's the game entity player, right? And also we have a list of game entities, right? So that for the game, they can maintain multiple entities, and each entity should be connect to element in the UI part, right? Food number, so here is food. Okay, all right. So they have two subclass, player and food. We look at the two subclass. So food. Okay, so food super called super because it's a game entity, right? So set x random place, set y random place, right? Also, we try to give a little bit of variation. If math.random, so this return a random number between 0 and 1, right? It could be 0 theoretically, but the chance is very, very, very small. So it's come to here. If it's larger than 0.5, so about 50%, so it's going to move, right? Random, so set the random move direction. Otherwise, it's just do not move, right? Okay, and also we put the life of food is thread local random current next integer. So we try to provide a life between 5 to 15 seconds for this food, right? Okay, so process, we just process move get type food, right? Entity type food. Response, we take override false because by default it's true. That means object move to the boundary is going to bounce back, but this response is false, so that if move to boundary is going to be disappear. Right? Okay. So that is here. Enumerate print game type, and look, we have create an enumerate entity type. So in the enumerate entity type, we have only two different types: player and food, right? Player and food. And we have player. Player is this super. The size, we're going to use the game config, get instant, get size, right? And set direction 1, 1, right? Increase x, increase y. So this just the normal part. So this normal change. If the user press the different arrow keys, going to change the dx, right? If increase, decrease of x, set y equals dy is 0. Set this, okay. All right, so that is about the control. The process is also just a process move entity get type player, right? So not much difference from the food. So there is entity type, control entity, so that's section. Now we look at next one, frame rate. So this one we have already explained in game entity. add the process method called through the animation timer. Okay, so this we have already explained. So this is important part. So we have the entity, so that is in the model part concept, and we link sprite with them, right? So we need to change the game entity. Look here, in the UI part we have sprite, and we have the sprite interface. Now we have the game entity, right? To get entity. So this add a new one. Originally we have set XY, but we remove that because the position of the sprite is not controlled by sprite, is controlled by entity, right? So we don't need to have set XY in here. Set XY controlled by this, by the model part, by the game entity. Okay, so that's return the identity, they're going to get the position. And also we have update. So this update is going to update the this sprite, right? The reason we need this update because this update is also related to this get node, right? So the get node. So this update is going to use for this get node to update. Okay, so that's sprite. Entity node should no longer create a visual object directly. Update visual from its sprite. Right? Okay, now we look at this class, this game pane. So this is actually the game running engine from here. So from this part, the previous one, we have the game pane, they have balls, right? Because they move ball around. And now they also may have multiple stars. Now they don't have them anymore. They have game, right? And also they have a list of sprite. Okay, so sprite create them. So in the game pane, because game pane controls the movement, it controls the game running, right? So this through this animation timer, and also it's going to call this part many times, 1 second. So doing call this, they're going to call this one game.process. So make the game continue to move, right? And also add sprites if we are going to have new sprite into this pane, and update sprite and remove that sprite. I call these 3 functions. Okay. Here, game pane should no longer create visual object. Update visuals from sprites. Maintain this one and add cursor node to it. Okay, see, let's check how could the game pane going to add their sprite, right? We look at this method, add sprite. Okay, so list equals sprite factory, because eventually the sprite is created through the sprite factory. Get factory, right? Produce sprite. So this is a method from there. We produce sprite. If list is null, so that no sprite create, we just return. Otherwise, for each sprite here, we put add sprite into our sprites, into our list, and also get children add sprite. So this new sprite add in dot get node, right? So we use this one to add visual element into this pane. Okay, and update sprite. So we just for each sprite in this sprite list, we call the sprite dot update, right? And also remove that sprite. So whenever they run, it's check if the sprite died or not. If died, remove from them. So we use this sprite dead sprite equals sprite dot stream filter. If check the sprite is dead, and we're going to list. If this is empty, that means no sprite dead. We just return. Otherwise, we remove all the dead sprite from current sprite. And also, this is a sprite. Also, we need to remove the visual object, the nodes, right? Get to remove all the dead sprite stream map to get node, remove their node to the list. Okay, so that is the logic in the game pane. updated sprite factory. So the sprite factory acts as a middleware between game and game pane, right? When game generates new entity, it's sent to sprite factory. Sprite factory create corresponding sprite and its associated node, right? So this we look at, because you see this add sprite is from the factory produced sprite, right? Okay. So how could the factory know when to produce sprite? We look at the factory. Okay. So the factory has a list called the entities. Okay. So the game entities, because each sprite is linked with one entity, right? So the game entity, if there is entity come to this factory, the entity dot add entity, because it's factory. The entity is more like the orders, right? I want to order some things, the entity add to this entity, right? Okay, they just add this to this list. Eventually, when they call the produce sprite, they look at entities is if it's not empty or not. If it's empty, we return null, right? So we don't need to create any sprite because the entity is empty. Otherwise, we have list sprite, return sprite equals new array list. So while entity is empty, if the entity is empty, if not empty, right? If not empty, the game entity equals entity remove the first entity from this one, and sprite equals produce sprite based on the entity, right? And return sprite add this one, and return this return sprite. So the return sprite is going to be catched by the game pane, the sprite create, and then use this one to add to their list. Okay, so look here, this key part is produce sprite based on entity, right? Produce sprite based on entity. So look at this method. Produce sprite, so this private method. So we have game entity here with, we check the type, the sprite type. The sprite type is the entity sprite mapper, because for each entity they have a type, but this type is the entity type. And we convert this entity type to sprite type. And then based on the sprite type, we're going to create a sprite, right? Create a sprite. And also we put the entity as the argument, so that's inject into the sprite with the entity. Okay, so we look at the mapper. So the mapper we have already introduced. Oh, haven't. This is the entity sprite mapper, right? So this just has one static method. So they convert from entity type to sprite type. So entity type can be food, can be player, right? Player to the sprite type player, and food to sprite type to star, right? Okay, so that's the return is sprite type. Sprite factory. We look at factory. They create them, and also return from the return this list from this method, right? So we continue. See what happened. Sprite factory removing that entity, right? In game entity added life attribute. If to this we have already explained that code. When an entity's life expires, it's died, right? Design makes them to remove entity from the game, remove its corresponding from here, right? So in the game we have the process, right? In the process, for each of this entity, we process each entity, and we remove dead entities, right? Remove dead entity. Remove dead entity is here just for the entities. Remove if game entity is dead, right? So just remove if it's dead. And also in the game pane part. We already mentioned the sprites remove that sprite, right? And also the children remove the node associated with that sprite. So that is implement player sprite, create new class player sprite and ball, right? So this one we have already explained. So that for sprite part we have sprite and also the player sprite explained, and also the ball, right? So the ball. So it's just extend the circle, right? So that is okay. Food and associate star sprite with food. Okay, so it's at the start of game create 8 food items, some moving randomly, some stationary. So we create the in the game, right? We call the fill food function. The fill food function, current food equals get entity number food. So it's because all the entities in the list of entities, right? So if you want to get all this type, uh, just return entities string filter get type equals type, right? Dot count, return how many of them. This also need to have a cast because this return a long, right? It's cast to integer. Okay. And get this if current food number times 2 larger than food number is 8, right? We have defined food number is 8, then return. Otherwise, we want to have that number, so integer I equals current food number, I is smaller than food number I plus plus. We create new food, right? And add this one. And also look here, if we create a new food with sprite factory add entity, right? So how do we know how the factory knows what kind of sprite they're going to create? So it depends on the game. If game create an entity, they're going to add this entity to the factory. Similarly, if we look at here, initial game, we have new players, right? We have entities add player, and also we have sprite factory add player as well, right? Player set this location. Okay, so that is a way to for the factory with the game. Once game create entity, they call the add entity to the factory, and then for the game pane they call the produce sprite from the factory. They're going to produce associated sprite from there, right? So that is the way to link. And look, yes, so for the process, so this process, game process proceed. So this one is going to be called by the game pane through the animation tabler many times a second, right? So for each entity we process, this process usually process move and also remove that entity. So once the process is going to check if any entities died, right? Remove that entity. So remove if game entities died, right? And fuel food. So if there's not enough food, we're going to fuel food, right? Okay. Fuel food. Movement behavior. The ball bounced back when hitting the edge of this game pane because it's bounced true. The foot moved out of the die, right? So we look at this. So for the player, it doesn't override the game entity. It's bounced, right? It's bounced, so they return true. But for food, they override this function, so the response return false, right? So that now we have a look about the gameplay. Now we have the gameplay, right? Right, so you see here you can control this ball. You can see this ball move that's going to bounce, right? And the star, they also some star moves, right? They move out of the boundary, they just disappear, right? Some of them die because each one stay there for 5 to 15 seconds. And once the number of stars less than four, they're going to create a new star, right? So it's like this. Okay. So now we don't have the ball can hit the star yet, but we're going to add that feature later on to make it more complete game. And also you can see this configuration still work as before. If we enable shadow, can here get large one. Come to game, say we're going to have a large ball, right? So the configuration part still work as before, right? Okay. So even though it does seem they have a lot of new function, not a lot of new function, but we can see that this week, this game has much more uh, design sections here, right? This design, even though they don't really add a lot of new features in the functional requirement functions in the game, but this make this system become more extendable. We can easily to add new behaviors in this part, and also all these classes, the functions are more focused for each of them, right? Okay, so this is the design for the code section for this week. Right. Sorry, I think it definitely takes some time for you to finish by yourself, but it's worth the time. Try to do this exercise. Try to finish this exercise by yourself. If you find too difficult, you can just get my code and try to look at them and copy some of them. It's fine, but try to reproduce all these features and understand why this design can be used. And now we look at the uh, class diagram, right? We look at the class diagram. So here we have the class diagram. Okay, so look at the class diagram. We have game entity, so that's abstract class. They have dx, xy, dx, dy size, burst time, life process, get type is died, right? So we have two concrete class, player and food, right? Okay, so this is part of the interface because get node return this one, right? So it's one-to-one relationship. And also in the game, we have entities, a list, right? So that's one of many here, right? Okay. And look at this part, we have game pane. So this game pane contains multiple sprite, right? And the sprite, they have two, because it's interface, so this abstract class is slightly different. Here we use implementation, and here is the extension, right? So we have player sprite, have ball. Oh, sorry, this is wrong. This star sprite, this should be star, right? This should be star. And we have game config, because for these simple classes, we probably do not need to uh, show their attribute and method because they are simple, right? But just show the relationship. That's enough. We have the game part of the game, and the game and the game pane is through the game factory, right? To game is going to send game entity to here, right? 8 entities, and also the game pane through the produce a sprite, right? Produce sprite, and also look at the code for some part, particularly in the game pane section. Look at the game, not game pane. Look at the sprite factory, because for sprite factory we have the entities. So entities can be modified through this code by the game, right? And also could be accessed by the game pane through the produce sprites. So both of the methods going to modify these entities, right? The entities going to remove, add. So therefore we put synchronized, so make sure they are not going to be, when they do this, they're going to be locked. I don't want to have some risk conditions, so that is for the multiple thread things. We use synchronous to make sure they're not going to be accessed by more than one thread at the same time, right? That may cause the conflict. Okay. Okay, so that's all about the coding section for this week. Now we have a quick to check this week's lab quizzes, right? This week's lab quizzes. Oh, sorry, I need to switch to student account, right? We are student. Okay, we are student. Try this week lab quizzes. I checked the record. I found not many students to do the lab quizzes. I encourage you to try to do the lab quizzes as much as possible. The reason is in the final exam, we're going to take the question directly from same question bank. So use this one to practice. You also help you to do the final exam. And also this lab quizzes help you to strengthen your understanding and review the lecture content for each week, right? Okay, this I have done 2 of them. Probably the second one is not 100%. Try again. Okay, multiple choice. Non-match equals 5 is, so this returns something true or false, right? True or false. Return true if non-element are equal 5. Yes, non-match 5. Yes. So not return number. No, this is return is true or false, non-match. Okay. Okay. Which data structure best reflects Titan? Okay. Hierarchy, general hierarchy structure, so that is a tree, right? Okay, that is a tree. So this one usually like the folder structure, so that's a tree, not a stack, not a circle, not hashtag, it's a tree. Which of following will not trigger stream process? Okay, so for each, so this is the terminal operator, count is terminal operator, collect is terminal operator, so they trigger the processing. The map is intermediate operator, right? So they do not trigger the processing. Look at this question. List of Java is cool, right? And collect and join. Okay, so that's this Java is cool. Okay, so joined by the dash. List of 1, 3, 5. List stream map s plus s2 length, right? So return the s is the string plus length, right? To array, so comes string array, right? And array 1. So that's 3 element. 1 is the second one, right? So it's going to return 3 and plus length, right? So it's 3, 5, right? The length is 5. 1, 2, 3, 4, 5, 3, 5. Okay. And look at this exercise new hash set. For this one, add, okay. So add I model 3, right? Model 3 from 0 to 5. So the model 3 they could only have 3 different answers. There, 1, 2, right? Cover them, so there should be 3, right? Size should be 3. This one, list of x, y, z, x, x, y, x, character input stream, as child 0. So first character to set, right? Size. Okay. So the first character for each of the string, the first one just itself, x, y, z, x. So x, y, z. So to set, so that only has 3 different elements, right? So the answer should be 3, right? 3. That's value size is 3. Which of the following Java interface is commonly associated with observer pattern? Okay, observer, right? Observer pattern, runnable, so that is for multiple thread, comparable for sorting, for compare for sorting, serializable, so that is for one object can be serialized to a string, right? So no, so observer. What is the main purpose of the word design pattern? To allow object to change behavior at runtime. So not this, not to notify multiple objects when another object changes. Yeah, that's this one. To encapsulate requires us not to queue operation. No, not them. Notify. For the observer, one object is changed, so they can have multiple observers. Each observer will be updated, right? To notify update. Yes. Which feature is typically supported by general hierarchy pattern? Traverse of parent and children relationship, dynamic proxy, singleton, not string for background. Oh, no. Okay. General hierarchy, so from parent to child relationship, right? Like from the parent folder to subfolder, right? So let's see this one. This one, set, new hash set, list, hammer, okay. 2 sides, right? Okay, so there's 4, but 2 hammers, right? 2 hammers is a side, so the sides there, they have unique items, right? They combine these 3. Integer name list of 1, 2, 3, 4, 5, optional first even, right? To stream, okay, all right. Okay, so that should be 2, right? Okay, optional integer. Found first even name string filter found first. Okay, the value of get is 2, right? Get is 2. Yes, first even. Right. Okay, so the map, we have the frequency map, hash map. So that's character to integer, right? So for the character to C, that's 2 character array, right? So that's A, B, 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 C, right? Put the frequency get default character. If not exit, return 0 plus 1, right? Get B. Okay, so B appears 3 times. Right? So 3, right? Every time get 1. Data new hash set. Put. Okay, put 3 of them. String to integer, right? List of x, y, x. Put key data get key plus 1, right? So get x. So x put to 1. So each time they're going to add by 1, right? So originally is 1 and get 2x to 1, so that's going to be 3, right? Okay, data get 3. In the state pattern, where is the logic of happening given state stored? In the state pattern, where is the logic for what happened in given state stored? In individual state class, right? So that's separate the logic in individual classes rather than in the command, not in the queue, not in the contact class, no, not in the main class. So each of the logic should be in the state class, right? Okay, submit. See what we get. Okay, this time good, 100% correct, right? To map. Okay. All right. So that is Okay, thank you for watching. And if you have any more questions, please feel free to ask me. And definitely practice is important, right? To do the lab exercise, to do this lab quizzes, help you to enhance your knowledge and also review the content, right? So that's important. Thank you very much. Bye bye.